This lesson deals with supplemental problem 15.5. You can find this problem in the ECE202 ebook in the Chapter 15 Supplemental Problems on page 6. Suppose I have three coils that are mutually coupled to each other. Call them L1, L2, and L3, and there's mutual inductance between 1 and 2, 2 and 3, and 3 and 1. Can you write the mesh equations for this circuit using our model for a transformer? So back in our notes on page 15, we had a model where we're going to assign a current in each of the dots. I'll call it I1 for L1, I2 for L2, and I3 for L3. And I'll put those three inductors right here. So I got my voltage source V1, my resistance R1, and then I've got a controlled source relative to each mutual inductance. So the mutual inductance between 1 and 2 is going to be dealing with the current I2, and likewise from coil 3, mutual inductance, which would be SM13 times I3. And those will be in series with this coil L1. Likewise for coil 2, we have a mutual inductance between 1 and 2 times the current I1, and then the current I3 times SM23. And this would be the voltage across here, would be our voltage V2. And lastly, our voltage V3 would be across R3. And we've got mutual inductance from coils 1 to 3, so SM13 times I1, and then SM23 times I2. So now we're able to handle the mutual inductance effects between all three coils. Okay, let's write mesh equations by inspection. So we'll set up a 3x3 matrix with I sub A, I sub B, and I sub C. And then what's going to go in row 1, column 1 are all of the impedances in mesh 1, which is just R1 plus SL1. And there's nothing connected between the meshes now, all zeros. Row 2, column 2, the impedances that are in mesh 2, so it's SL2 plus R2. Again, all zeros everywhere else, no other connections. And lastly, for mesh 3, I've got SL3 and R3. That's going to go in row 3, column 3. Now, if you go around the mesh counterclockwise and record the first sign, you see that's going to go on the left-hand side of the equation. So I'm going to have minus this controlled source, SM13 times I3, and then a minus SM12 I2, and then a plus V1. Going counterclockwise around this mesh, I'm going to get a plus an SM12 I1, and then a plus SM23 I3. So I go in row 2, column 1. And lastly, going around this counterclockwise, again two positive terms. So SM13 times I1, and then SM23 times I2. Now, what is I1, I2, and I3 in terms of IA, IB, and I sub C? Well, here I sub A and I1 are the same. Here they're in opposite directions, and likewise over here. So now I could bring these terms with the mutual inductance on the other side of the equation in terms of the unknowns A, B, and C. So I have V1, and then I have SL1, and then I2 is minus I sub B. So when I bring it on this side, it's going to be a plus term, and then a minus I sub B, so I get a minus SM12. And this term, bringing on the other side of the equation, become plus, but I got another minus sign here, so I get a minus sign here. Likewise here, when I bring this on this side of the equation, it's going to be a negative of it, and it's going to be I sub A, so it'll be in column 1. This term here is going to be with column 3, but it's the negative of that, so I'm going to get a minus sign from the moving on this side of the equation, and then another minus sign here will cancel those two. And then lastly, bringing this on this side of the equation, we get a negative of that term, and then IA equals I1, be in column 1, and then this second term here will be SM23 times I2, but I2 is a minus I sub B. So when we bring it on this side of the equation, it becomes negative, and then another negative, so I get a positive sign. So now I have my mesh equations, and I can solve for any or all the mesh currents. And this is supplemental problem 15.5.